it's got torque sensing in all the joints.
Yeah.
So basically, when it makes a collision, it automatically detects an over torque. Then it just cuts out.
Okay.
So I believe, I don't know if Barry reset this, that we were having a slight issue. Okay. So what this line is here is it's showing us it's in line with the machinery directive, the state of the machine. So blue, yellow, amber for error, and white is in line with the machinery directive. I'm not sure the exact number.
The machinery what?
Machinery directive that dictates the regulations based upon, you know, the cone traffic lights that are on the machines, based upon the machine state.
All right.
This is all about ease of use, this robot. So what we've done is the idea is that it can work with a human, whereas that, or one of your AEV robots, needs to be in a cage or have some kind of guarding. This has got soft guarding. See that yellow LiDAR sensor there?
Yep.
So what we've done is we've created new software. What it is a visual-based software. So it's basically a flow chart of moves, and you basically populate those moves, or you can hand jog the robot.
So is that the pendant? So the pendant is up there? Ooh.
Yeah, so you can use a teach pendant. We do sell those separately, but with this one, it's a collaborative robot. It's safe to do so. We can go into direct teach mode. I think we'll hold this first. Right, so we're in direct teaching. So I can move it.
Okay.
Like this. I can move whatever. I can then press teach. I'm not going to because I'll mess up the program. But you can then press teach, and that's toy position. You can move it again, teach another position, and create your program that way.
All right.
Rather than actually programming it using that.
Yeah.
Right. So let me just.
But is that the way you're jogging it? You're jogging it by moving it. Is that the way you jog this one? Is by moving it by hand? Is how you jog this one?
Yeah, or you could do it via a teach pendant or via the software.
Okay.
It doesn't matter. But because it's collaborative, you're allowed. You can do that.
Okay,
it's
because
safe.
Okay, it's safe to do so.
We have, to make it ease of use again, we've got quick setup tools for a bunch of grippers and the cameras as well.
Okay.
There's a video on YouTube of how to set one of these up in 3 minutes. It's that quick.
Okay.
Moving on to the industrial arbiters.
All right.
So you've got, I mentioned earlier, the soft guarding. See the orange zone here?
Yeah, okay.
What we do is we take a step into the orange zone, and the robot's now slowed down, so that's a safe limited speed.
All right, okay.
Okay, we then step into the red zone.
And it stops. Okay. All right.
So what this is doing, this is making an industrial robot safe to not have to be in a cage. However, it can't move as fast as if it was in a cage. There is still a limitation on the speed. I believe it's 1,000 millimeters a second.
Yeah.
Whereas if it's in a cage, you can go up to 10,000.
So it's not 100% now. It's not going at 100%.
It's not moving at 100% speed.
Okay.
I think it's my shoulder. There we go, and it goes back.
Okay. That's cool.
This robot is set up actually this is our predefined HMI templates for robot operation. So let's just go.
So that's a software, but it could be a software for. You could use a software where you can install it in a computer. It doesn't have to be a customized HMI screen.
Yeah, it can be on a computer. Just this is one of our predefined templates that we can supply for HMI. So you don't actually need a teach pendant in theory. So this could be on the side of your machine, and you can jog the robot through this.
Okay.
Look at error information, monitor meters. Here is all the live values of the various different coordinates, different joints.
Okay, all right.
And what we do is we create these screens so you can. It's all pre-addressed. So basically, you can put this into your HMI project. Once you plug the robot together, it just knows because each of these is a buffer memory inside the robot controller.
Okay.
So it's literally set up in 5 minutes. Moving on to this next one.
That's cool.
Oh, sorry. I should probably come back here. Sorry. This robot is what we call an R-type robot. So this here is the robot CPU.
Okay.
This is the PLC CPU. And what you can do is you can have up to 4 CPUs of any type on one rack.
Okay.
Which means you can get collision avoidance amongst robots. So that's 4 robot CPUs all communicating at the same time, which means you can have robots all going in between each other and they won't hit each other because they know exactly where each other are.
They have to look for collision zone before they
Well, they'll know where they are at all points.
Okay.
Because they're communicating along the back plane.
All right. Okay. Yep.
And then you can have up to 8 of these PLCs all networked.
I think it's similar to what we have where I work, where we have
Self-contained articulated robot arm.
Self-contained articulated robot arm.
Yeah.
All right.
So it's 4 axes. Typically, they're a bit more accurate than a vertical arm because there's less movement axes.
Okay.
Actually, like there would always be a bit more chance for inaccuracy.
All right.
More axes of motion there.
If you were to use this one for to put a torque tool, you could put a torque tool underneath it. Anyway, I don't know, but we use those ones. We put torque tools in them. They find where they have to screw in the the mount screws and all that. And
so those screws are probably in a fixed position because in JLR, I'm assuming it's being presented in exactly the same position every time.
Yeah.
So the robot isn't finding that position; it's programmed in.
Yeah, it's always finding that position. Yeah.
Yeah. Whereas with this, so again, this is using a similar safe soft guarding solution, but this is a dead stop.
Okay.
And it's using these 6 sensors.
Okay.
So if you know, it's basically a mirror.
Yeah.
It's a laser shining into that, and it goes around.
Okay. All right. Yeah, I know about this one.
Right. Okay, so this is using one of our collaborative partners, Aziril. They've got a stand over there.
Yeah, I've seen them down there. I think I saw them.
Placing ball bearings into there, vibrating them, and then the camera is taking a picture, telling the robot where to pick the ball bearings from.
Unload all the parts.
So it's random.
Yeah. So. All right.
The red flashes when it takes a picture.
Yeah,
It tells the robot where to
it doesn't have to be in the same place. Just finds it where it is, wherever it is, and within that confinement.
Yeah.
All right.
Obviously, when you're using vision systems, the application's slower just because of processing time of the picture and stuff like that. If the robot has a fixed position that it always has to go to, it will be way faster.
Okay.
Because the robot's just running a program, it's not having to interface with a camera or anything like that. And that's the same regardless of robot manufacturers, it's just computer processing.
Yeah, I understand. They work with the one they call the Perceptron. There's one they call Perceptron or so. That's the one we work with. But it's interesting to know all this. I saw this on the other side. I was like, does Epson make robots?
Yeah.
So Epson doesn't make robots, but what you do is that they work with you. They work with your robots. Is that how it works?
Epson make robots.
They make robots. Oh.
Yeah. However, this is a direct competitor.
Okay. Because it looks like it looks more like it looks like the one they have
It looks
over
very
there.
similar, doesn't it?
Yeah.
I believe footprint is exactly the same.
Okay.
And they're direct competitors for each other. The Epson products are good products at the end of the day. This is one of our low-cost robots.
Okay.
So list price,
But it actually
10 to £12,000 for this unit.
Yeah.
It's 6 kilograms payload.
how much does the small industrial robot cost?
This one
Yeah.
here?
Sorry.
It's an RV7. So you're talking 24.
24 grand. Okay.
Yeah. And then that's around 25.
Okay. But you make big ones as well. You make the big ones.
We got up to 20 kilos.
So this one is how many?
7 kilos.
7 kilos, 20 kilos. Oh, right.
We do have a range of even bigger, but we're making them obsolete.
So
we're not selling them.
So robots are measured in kilos. Their
payload.
capacity of what they can lift.
Yeah.
So this can lift up to 7 kilos. All right.
Including the gripper.
Then the gripper. Okay. All right.
In that. So you've got to make sure in your payload calculations that you're including that, as well as whatever you're picking up.
All right. Okay. All right. Thank you so much.
No worries.
A few.
You like it?
Yeah, but does Epson do automation as well?
Do we integrate? Is that what you mean? Do we integrate?
I thought Epson was a company that does
Printers.
That's
No.
what I knew.
Epson are the largest manufacturer of SCARA robots in the world.
Okay.
They sell more SCARA robots than anybody else.
All right.
So you've got 2 robots here, you've got 2 level.
Okay.
Both repeat to 10 microns. Yeah. That one is a controller and robot arm all in one.
Okay.
This one has got a controller underneath.
All right.
That one can probably do, depending on the cycles, up to 90 cycles a minute. Like a sewing machine.
That's quite fast.
This one, 30 to 40. But that one's 6,500. And that one's about 17, 18.
Okay.
And that is an excellent motor.
I've got to draw a map of Scotland now, haven't I? They do all maps on there, don't they? Aberlour, it's a famous whiskey from Aberlour. But it's quite big. It sounds like we'll be taking at least a minibus there. Just the principle to go. So if we go there, we'll have to make a minibus and everyone will go. They want to get some shortbread.
In Jaguar Land Rover, that the part where I work we didn't have them. We have the big ones there because we do the framing, the body, the framing of the cars. So they basically use the big ones, the big.
I think we've been Jaguar Land Rover quite a bit. We were at BMW.
Okay, all right.
BMW. If you look at the late long BMW 1 Series advert, robot, the hand comes across and the robot comes across and touches.
All right. Okay. All right. So you have big robots, so are they all of the size, or do you have bigger ones?
We have bigger ones, so yeah, we start at this size.
All right. All right. Okay. Where I work, they have mostly ABB robots, but industrial robots. So I mean, I don't know very much about them. I'm still trying to learn how the robots work.
With your ABB, you're looking at industrial robots. The UR robots that we provide.
So these are flat motors that have been pneumatic cylinders have been replaced with flat motors, which. So these are 2 cylinders that are not joined together. Cylinders. So this is not controlled by a pneumatic system. It's a flattened out motor. So instead of pneumatic, you use electrical motors to control these cylinders. Direct replacement for, instead of using electric, you use pneumatics for it. Instead of using pneumatic, you use electric to control the system.